Welcome everyone. This is another video that will go over some of the stuff that we're learning right now. I think the week that I was gone, you had some notes. You either did them on maybe Thursday, that was solving linear systems by graphing. And in that video, you were told to graph one equation, make a table, graph one equation. You take the second equation, you make a table of values, and you graph those two equations on one coordinate plane, and what would result is these two lines would intersect, and from that intersection point you would find the solution that would make both these two equations be equal on the left and right hand side. And what was significant about that ordered pair, it was solution to both of them. What we're doing today is basically the same thing, but instead of using graphing, we're going to use elimination. Specifically, there are basically two types that we're going to learn today. One is called addition, and you probably guessed that the other method is called subtraction. Like a 2x, and we wanted that 2x to go away. If it was positive, we would subtract it. If it was negative, we would add it. So this is kind of the same idea with just a different twist. If you go ahead and look at this variable right here, let's look at the x column first. You can see that the x's have different signs. And if you take a look here at the y's have different signs, but what's interesting about the y's, they're not the same value, whereas the x's are the same value. What's important about this is the idea of the additive inverse. And if you remember what the additive inverse, it's basically two numbers that you can add together to get 0. So, for instance, if I have 2x and I add a negative 2x, I equals 0. If I have, in this case, if I have 1x and I add a negative 1x, I also get 0. So the idea is this. We're going to use the additive inverse to get one variable drop out, and it will leave one variable here. And what's significant about having an equation with one variable is that you can only solve equations that have one variable. Let me finish writing this down, and then we're going to go ahead and get started here a little bit. You can see how everything goes. Alright, so let's go ahead and zoom out and we'll get started here. So on the first 6 problems that we have here, you're going to be using addition. So problems 1 through 6, you're going to be using addition to be able to get a variable to drop out. Once that variable drops out, you're going to have a remaining variable, and then you're going to find it, and we'll take it up to that point and we'll do some more writing over here. Just looking at number 2, we look at 5x minus y equals 14. We have a negative 5x minus 5y equals 10. The first thing you want to look for is to look at each column and see if the additive inverse is in play. And if you look at this column right here, you can see that the additive inverse is there. This allows us to add these two variables together, like variables in the same column. They're same idea as like terms, and when I add those together, do you see that the x's drop out? I end up with a 0x, so those x's are gone. And if I look at the y's, we have a negative 1y plus a negative 5y. That'll give me a negative 6y. By adding these two equations together, I get a negative 6y equals 24. Now that we've had the x's drop out, we get a variable that only has, or an equation that only has one variable in it. That allows me to take this. I know to get the y by itself, I'll divide each side by 6. The first variable that I have for y would be 24 divided by a negative 6 will be a negative 4. This means that part of the ordered pair that solves this equation right here, the y value is a negative 4. The x value I don't know yet, but we're going to find that out. So as a recap, the first thing that we do is we look for the additive inverse. If it's there, we're going to go ahead and add the equations together. Remember, the additive inverse, the numbers have to be the same. They have to vary by a sign, correct? This has the additive inverse. This also has the additive inverse, and we'll do this one here in just a minute. The third step, after finding the first variable, substitute its value into the first equation. So after finding the first variable, we'll just say put its value into the first equation. So if you need to pause the video to finish writing this down, go ahead and pause it, and then when you're ready we'll go on to the next part. I found that y equals a negative 4. I'm going to take my first equation. I have 5x minus, and I'm going to put a negative 4 in for y, because that's what y is, equals 14. Now a double negative will make this y positive, so be careful about your signs on some of this, because when we substitute values in, if I already have a negative there and I'm substituting a negative value in for the y or for the x, you're going to have a double negative sometimes, so be careful. Now look what happens. I end up with an equation again that only has one variable. You see how this equation had one variable in it right here? The x is dropped out because of the additive inverse. Well, the second time around, the y is going to drop out because I'm going to use its value right here that I found and put it into the original equation, so I get one that just has an x. Now I'll go ahead and subtract 4 to each side to get this value to go to 0. That goes back to chapter 1. I get first quarter, and then now this equation right here ends up being 5x equals 10. To get x by itself, I divide each side by 5, so x equals 2. Now for equation number 2, we finally have the value for x. X equals 2 and y equals a negative 4. So this means when these two equations, if I were to graph them, they would cross at the point 2, negative 4. Now let's review how we check this. Let me pull up a calculator. Now remember, I put 2 in for x, a negative 4 in for y, and that should give me 14. So I have 5 times 2, subtract, right, subtract, and now in parentheses I'll put the negative 4, and then when I hit equals, it better be 14. If it's 14, I've got the right answer. This means it works on the first equation, so that one's good. Now I have to test the second one. A negative 5, my x is 2, and then I subtract 5 times a negative 4. And if I've done this equation right, I should have 10. There, it checks out, doesn't it? The first equation equaled 14. The second equation is supposed to equal to 10. That means that I do have the correct ordered pair. Now remember, your final answer needs to be written as an ordered pair. Remember that the x value goes first and the y goes second. That's a common mistake that students often make. So there is your answer for question number 2. Okay, I'm going to erase, take a minute, write down number 2 all the way and pause the video if you need to. I'm going to erase it, and then we're going to do number 1 over here. I'm going to take these notes and slide them over here to problem number 2, and then we'll go ahead and do number 1. We can see the additive inverse in play. So I have x minus x. We have 7y equals a negative 4. And negative 6y equals 2. The additive inverse is already there, so I don't have to do anything. We'll add them together. That goes to 0, so the x's drop out. Now, on the 2 problems that we've done, the x's have dropped out, but you can have the y's drop out just as easy. 7 add a negative 6 will give me a 1y. Negative 4 plus 2 gives me a negative 2. I also have y equals a negative 2. I guess the last one was a negative 4. So y equals a negative 2 on this one. Now remember, you only can solve an equation that has one variable in it. We've got the one variable to drop out. That allowed us to solve it. Now after finding the first variable, you're going to put its value back into the first equation. We'll put it back into the first equation. That will give me x plus 7 times a negative 2 equals a negative 4. X minus 14 equals a negative 14, or a negative 4, excuse me. So x minus 14 equals a negative 4. Now I want to get the x value by itself. I will add 14 to each side. That goes to 0. This goes to 10. That tells me that x equals a negative, or equals 10. So x equals 10. My ordered pair solution for this is, remember the x goes first, so the 10 goes first, the negative 2 goes second, and there we go. Let's take a minute and go ahead and check it. On these equations, there should be no reason why you can't find the solution on everything, because they're so easy to check. When you substitute in a variable in an equation, make sure you use parentheses around it. It's a negative 2 for the 10, and it better be a negative 4. I have the first one right. Now let's go for the second one. I have a negative. Remember, when I sub in a variable, I use parentheses to show that I substituted the variable with a number. Minus 6, and I put a negative 2 in there. And if I have this right, it better be a positive 2. I do get a positive 2, so those are the 2 solutions. Okay, so the additive inverse, remember you're looking for that additive inverse, and this is what it looks like. The second principle is you only can solve equations that have one variable, so you have to get a variable to drop. Let's go ahead and add that. So you have to make variable drop. I think I'm just a little bit out of room over here. Let me scoot this over. Okay, now you'll be able to see that a little bit better. And then step number 4, is you want to solve the equation for step number 3. And step number 5 is you want to write the ordered pair. And remember, that has to be an X and a Y. And then last of all, in this step, you always want to check your work. So check your answer. Okay, I'll get set up and we'll do some that have subtraction. And if you know how to add, you know how to do subtraction. It'll be pretty easy.